Hey guys, how's everything going? This is JSer. In this video, I'm going to take a look at 1 to 7 word ladder. We're given two words, begin word and end word, and a dictionary. We need to find the length of shortest transformation sequence from begin word to end word, such that only one letter can be changed at a time, and each transformed word must exist in the word list. We need to return 0 if there's no such transformation. All words have the same length, and all words contain only Newark alphabet characters. We may assume that no duplicates in the word list. So, for example, we get hit and cog, and the word list of this. Of course, we can transform hit to hot, and then hot to dot, dot to dog, dog to cog, right? So there will be five words: 1, 2, 3, 4, 5. And then this one, hit to cog, we have hit, hot, dot, dog, but there is no cog in the word list. We are asked that each transformed word must exist. So we cannot do that. Well, it's actually like wait a minute. If we it's actually if we think of these if two words could be transformed, we draw a line like hot dot. We could draw a line. It means we could transform hot to dot or dot to hot, right? And then dot to dot, also we draw a line. Hot to dot, draw a line. We could process the word list and draw the line, and it will become a graph problem. So it means the end word must be in the word list, right? If not, we return 0, and then we could search for hit. We check for all the nodes, check for all the word, and if they can be transformed, and then we will start searching for the target word from that word, right? From that word, yeah. And that was a typical BFS problem. Like we're going to search dot, the shortest path from dot to cog, then we put the closest word in a queue, and then do it round by round, and we'll find the cog with the path count. Cool, so that's it. So the idea becomes clear now. One problem is that do we need to process the word list, or just because we only search for one word at a time? Maybe we could just do the search and the match at the same time. I mean, we loop through the word and check if a hit could be interchangeable, transformable. Why? Because anyway, we will loop through all the words. Yeah. If we start from G dog, and then we check hot, and then we check dog, and then we need to check it again. So yeah, there will be duplicate. I will pre-process the word list, create a graph, and then try match the begin word with all the nodes in the graph, and this will be done in a substep called BFS the target. Update the shortest path, right? Something we need to could be addressed is that we could return fast, right? If we found return not fast but immediately if end word is not in the list. Cool. Now let's begin. First we get a graph. We could use a map to do that. So let's create a transformable new map. This map should be, this should be a map of string to set string, right? And this should be for let. We loop through all the word pair. And before we do this, we need to create actually a util function is transformable word 1, word 2. How we do this? We will just count the different letters, right? So the words have the same length. We are guaranteed. If we found a different word letter, we count it +1. If it's bigger than 1, then we return false. And then we return okay, return true. I think we could just use a flag is different found false. We update this to set it to true. If it already found, then return a false. Okay, now we just check it. So the map would be two-way, right? Hard to dot to hard. Wait a minute. If I say hard dot and cog, yeah, it's two-way. Okay. Okay, we just use two-way. If is transformable, word list I, word list j. We need to add these two words pair to the map, right? So let's do it. If transformable password list I, then we get it, and because it's a set, we add word list j. If not, we will set it to a new set. New set is word list j. Okay, and we need to add it the backward, right? So j I. Cool. So now we have done the map. Now we need to try to match the words, all the nodes in the graph. Okay. And BF is the target. So for let I, should we, is in the list? I need to transform this into wait a minute. Okay. Should we keep all words? If we do all words, maybe we could just do it backwards. Like we first choose cog target and then do BFS, right? And then we could, oh yeah, I think we have improved it. We could improve it. Yeah, do it backwards. Check the length, transform like path. Then for all the words from target end word, right? BFS. And then 3 match begin words against all. Cool. Okay, so for that case, I think I need to create all words set, right? So all words equals from a new set, and allow me to add all words, add word list. Okay, I'll just transform. Okay, const all words equals new set, which is word list. Cool. And then we can return immediately. Is here. I mean, if all words has, if it doesn't have the target end word, we return 0. Okay, now we have it. Okay. BFS. Okay. So we now do BFS, which we use a Q. We put the target word in it, which is end word. Q is not empty. So the current let step equals 0. Oh, okay. Steps, yeah, 0. But we need to also mark the Travis word, right? So I'll say const marked is a new set. Or no, we could use the old word. Wait a minute. Why we need all words? We already set it, and we will start from a transformable. We don't need, so we don't need the all words actually. I'll say the all words steps from end word. New set, new map actually. We create a map. No. Wait a minute. I think I just need to mark if one word is traversed or not. I can use a set. If that's the case, I think we can say it if it is available or not. So we use all words, right? Okay. All words available words. Okay. And then we can just check the word if it is available or not. Cool. While it's in it, let's push a null as ending identifier. While head equals q shift. So we need to update the words in it, right? From it. But where do we keep the step? If it is already marked, yeah. While this set is not useful. I think I don't need this one. Okay, let's see. Is end word found? False. I'll add a condition, add a check here. Okay, let's just start from I, but we will skip if I have it equals to j. I'll just to make the code cleaner okay, no. Start from 1, but if word list I is our target, we set it to true, right? We found we will initialize with the last element. Cool. So we now has this flag. If not found, we return 0, right? And then we could use a map called steps map. New map. This should be a map of string word. I'll say word steps. Okay, we get the head out and we will update the steps, right? So steps map set head to steps. And after this is done, we need to update the steps. And okay, we set it, and then we will push the next round of words, right? Which is from the transformable. Okay, so next words be get head. If it's not null, undefined, we will loop through it. Let next words. We will push into the queue. Will there be same word? Yeah, it might be. So we will push only still not okay. When we push it, Okay, we could just we set the when we set the steps, we don't check if it is in the map or not, so we just push it. Okay, so we get the word if the step map has next. If it doesn't have it, we push it, right? So Q, we will push the next. And don't forget to mark it, set next. Steps should, okay, 0 is okay. It will be updated when it is shifted. So, cool. And then finally, we will, it is working, Q, get it, and set the steps, steps +1, and then get the next round word, like cog, we will have log and dog, right? And then these two will be pushed it in, because steps maps doesn't have it. And we push it and set the word. This will be caught again, so no problem. Okay, the last one we will start from the begin word, right? So for we only need to search for the smallest one, which is in the steps map. For the word that is cannot be reachable, it will be not in the step map, right? So let let result equals be infinity for let the word of steps map and this is the steps. Okay, I made a mistake. The steps of itself should be counted as 1, 2, right? So we start with 1 and set it. This is 0, doesn't matter. It will be updated anyway. Cool. So here, if the word could be transformed from this, could be transformed from begin word, which is begin word, then I'll say this is a possible path. So math main result with the steps +1, right? Suppose cog, it will have 1 step to log, dog, and 2 steps to dot, 3 steps to hot. So we got before here, hot, and +1, 5. Yeah. And then we return result. If it cannot be there, we return 0 and then return result. It should work. Whoa! Bug free? Really? Yo, yes! First time, man. Okay. Wow. I feel so good. I can have a good sleep tonight. Huh. Okay, so the time and space complexity, let's analyze. This obviously is for linear to the letter count, right? Suppose n word of k letters. So here should be OK. This will holds all the map words, so space is linear space. This will be on to the square. Quadratic because we need to check the the space here is not space here because we just said actually, so it's not here linear. It should be quadratic. and this is a time space. First, this is time complexity, quadratic. We use a new map here, linear space. We use a queue. Well, so worst case it's still linear space, and this will be while loop, so it's obviously it's linear time, and here linear time. We will check all the relationships, so it's quadratic time actually. So time total, it's quadratic time and quadratic space. This is my approach. Anyway, so the idea is basically very simple, I think, but the implementation is little verbose. I suggest that write down the steps 1 and 2 and 3. Write it down. The interviewer might understand what you're doing, what we are doing, right? Clearly, and we can then write some skeleton code, and like here is transformable. I'll just leave it to do. I'll say okay, I'll implement the important part first, and then like here, like the BFS, I'll write it first, and then okay, if I have time, I will, because it's very simple, I will write down the idea here and just leave it to do. So that's it. I hope it helps. See you next time. Bye bye.